Okay guys, so in this lecture we'll be discussing on the empirical formula and molecular formula. Okay, so molecular formula represents actual total number of atoms of various elements in a molecule. Okay, actual total number of atoms of various elements in a molecule. Of various elements in a molecule. Okay, and suppose we have a molecular formula of just an example of glucose. So it would be C6H12O6. So it is glucose. So it contains, obviously it has a molar mass of 180 gram per mole. Okay, so one molecule of C6H12O6 contains 6 atoms of carbon and 12 atoms of hydrogen and 6 atoms of oxygen. Okay, so one molecule of C6H12O6 contains 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen. Okay, and similarly 1 mole of C6H12O6 contains 6 moles of carbon, 12 moles of hydrogen and 6 moles of oxygen. Okay, so the simplest ratio of atoms would be C is to H is to O, which would be 6 is to 12 is to 6 or 1 is to 2 is to 1. Okay, so the empirical formula for a molecule of glucose would be CH2O, and similarly for benzene it would be benzene's empirical formula would be CH, because the molecular formula of benzene is C6H6. So empirical formula is the simplest whole number ratio of atoms present in a molecule or in a molecular formula of a compound. Okay, so let's write it, that it is simplest whole number ratio of atoms present in a molecule. Okay, so also there are some compounds which have same molecular formula as empirical formula. So in case of we have, let's say, sucrose formula is, or rather molecular formula is C12H22O11, and this would be same empirical formula as well, same empirical formula and molecular formula. Okay, so just a mathematical representation that molecular formula can be written as empirical formula times n. Okay, where n goes from 1 to 3 and so on. Okay, and similarly molecular mass can be written as empirical mass in times n. Again, n varies from 1 to 3 and so on. Okay, so let's say we have a question in which we have an organic compound which contains 92.3% carbon, 7.7% oxygen. These are by mass. Okay, if the molar mass of the compound is 78 gram per mole, molar mass of compound is 78 gram per mole. So you have to find the empirical formula and molecular formula of the compound. Okay, so let's say we have 100 gram of compound. So now what happens? So mass of carbon in this 100 gram would be, mass of carbon would be 92.3 grams and mass of hydrogen would be 7.7 grams. Okay, so the relative number of moles of carbon would be 92.3 over 12, which is the molar mass of carbon would be 7.7, and relative number of moles of hydrogen would be again 7.7 over 1, which would be again 7.7. So the empirical formula, or rather the simplest ratio of moles of C and H is, simplest molar ratio is 1:1, hence empirical formula would be C and H. So molecular formula, as we discussed, would be CH times N. So we know that the molar mass of CHN is given in the question, which is 78 gram per mole. So CH is nothing but 13 into N is 78. This implies N would be 6. Okay, hence empirical formula, or rather molecular formula, is when N is put as its value is 6, hence molecular formula comes out to be C6H6. So this is the required answer. Okay, so empirical formula is CH and molecular formula is C6H6. So with this we come to an end of this lecture. In the next lecture we'll be seeing some more questions on empirical formula and molecular formula, and then we'll be seeing the calculation of empirical formula. Okay.